Question 14a. Use integration by parts to find the exact value of the integral of x squared cos x dx. Okay, so your integration by parts formula is in the formula book. Okay, and it is this in simple terms. I mean, in the formula book it writes dv by dx's and du by dx's, but this is basically what it is. So it takes a product and it turns it into something else, and hopefully this second integration is easier than the one you began with. So when you're choosing which is the u and which is the v dash, if one is a log, then that has to be the u, but we don't have logs. So the next thing is, if there are any algebraic terms that are going to get easier as they differentiate, then that's your u. So that's going to be my x squared. So u is x squared, so u dash is 2x. And then we'll have v dash as cos x, and v therefore integrates to sine x. Okay, so remember with this formula, the two things you're starting with are not u and v, they are u and v dash. Okay, so let's put this into the rule. So this is going to equal your u times your v, so x squared sine x, minus your integral of your u dash times your v, 2x sine x. Okay, now the problem we've got is this is still a product, but it's got a bit easier because this isn't now a squared term, this is a linear term. So if we run through the rule for a second time, so do the rule within the rule, we should then be able to finish it off. So we're going to go again. So u this time is going to be 2x, and u dash will be 2. V dash will be sine x, and therefore v is negative cos x. Okay, you do need to make sure you know your differentials and integrals of your trig. Okay, let's move along, give it a bit more space. So I've still got the first term. I've got a minus, and I'm going to put a big bracket because then it's minus everything I write to do with the product rule for this one. Okay, it might just be that sort of thing that trips you up, so just be very careful. So I want my new u times my v, so I've got a 2x times a negative cos x. Let's pop the minus sign at the front. Okay, take away from the formula my u dash times my v, so the integral of 2 times negative, put it at the front, cos x dx. Close the big bracket. Okay, so anytime you're timesing by a negative, you know, when we times 2x by negative cos x, or we times 2 by negative cos x, just throw that minus sign right to the front straight away. Okay, we've got lots of minuses going around, and we've got an integration to do. So I'm going to keep the big bracket for now and just deal with this bit here. I don't want to do too many things in one line. So this is basically going to be 2 minuses making a plus, and now I can ignore both of those minuses and just figure out the integral of 2 cos x, and cos integrates to sine. Okay, so I've dealt with the minus to make a plus, and cos integrates to sine without a minus. And then I can put this minus sign and get all my terms. So that would give me then a plus for that term, and then it would give me a minus for that term. So you just, as I say, you have to be really, really careful. And now we can do the limits. Pi by 2 and 0. Okay, so we've got pi by 2 squared sine pi by 2 plus 2 times pi by 2 times cos pi by 2 minus 2 times sine pi by 2. Take away. Now that's going to be a 0. Doesn't matter about the trig bit because the x is a 0. That one's going to be a 0. That one is minus 2 sine 0. Okay, we are in radians again because we've got integration, and trig is always in radians when we're integrating or differentiating, and my calculator is in radians. I just want to figure out the trig bits first. I don't want the decimal because it says the exact. So just work out the trig parts of all of these. So I've got pi over 2 squared and then sine of pi over 2, which I shouldn't need to do on the calculator, but I'm just showing you, is a 1. Okay, so that's just a 1. I've then got 2 times pi by 2, which gives me a pi. Cos of pi by 2, oh, well, that's a 0. So that term disappears. Sine of pi by 2 was a 1. And then down here, that disappears, and 2 lots of sine 0 is also 0. Okay. Right, nearly there. The exact value will be, now I'll square this because I think it's probably nicer to write it as pi squared over 4, take away 2, and that's it. Done. Hopefully that's correct. Let's double check it on the calculator integration. Okay, so pi squared over 4, take away 2, as a decimal is 0.4674 ... Let's see if our integration comes out like that. We're integrating x squared cos x. I better close that bracket. And then from top limit pi by 2, bottom limit 0. Fingers crossed. Lovely.